All right. So very good morning. This is statistics for management, section 5 and 6. One for student BPC student. All right. So first of all, today's class might be a shorter class. Okay. These are the chapters we will go through. You can see here probability, random variables, special probability distribution. Okay, special probability distribution, binomial, Poisson, and normal. And then uh, in this is a such suggestion. Okay, suggested date on 7th week. We will try to have a test, and next sampling distribution, estimation, hypothesis testing, correlation, analysis of variance. Later I will share this with you. I will share uh, with section 5 and 6. Don't worry, this one. All right. So the lecturers are Dr. Hafiza, Dr. Amma, me, and Dr. Chan. These are some books you can find in library. All these books, and for assessment we will have. Okay, I will have one quiz, midterm, assignment. The presentation later I will explain to you. Okay, and then final. Okay, so all materials will be provided, all the solution will be provided, so you have to sit and go through all these things. All right, so now let us go to our first topic. So probability, many of you have gone through this probability in your school, so we will revise again in much detail manner. All right, I have sent this slide to you. All of you must have this slide, and maybe you can download and use your iPad or something to write, or if you print also can. If you don't want to print, you want to see from the phone and you want to jot down in some notes, okay, also can. So make sure you have some notebook, because only two first week is online. After that is going to be physical. So I will ask to do some exercise and submit on the spot. All right. Before we go to probability, the first thing is let us go through some important terms. Okay, some important terms. First of all is a random experiment. Random experiment. Random experiment is activities with several outcome. Okay, you can see here. Random experiment is an action or process that lead to one of the several outcome. Basically, what I mean is, if you do some activities, okay, if you do some something, and the outcome is more than one, then it is known as random experiment. Okay. Activity with several outcome, that is known as random experiment. All my notes, everything I will share with you. Okay, you want to jot down something, you can jot down, but all will be provided, including the session is recorded. Later I'll share the recorded video to you. So for example, activities of random experiment is flip a coin. When you flip a coin, you get head and tails. If you flip a coin and your outcome is only one, that is not random experiment. If it is more than one, then it's a random experiment. So for example, this I'm just listing down some experiment here. So flip a coin, you will get head and tails. Record marks on a statistics test out of 100, okay, in between 0 and 100, so there are plenty marks. Record grade of assist statistics test A, B, C, D, F, okay, so like that you can read it yourself, okay. That is random experiment. When you do a random experiment, you will get outcome, isn't it? All these outcome, all possible outcome, if you list out all possible outcome, if you list out, it is known as exhaustive outcome. For example, if you have this is let's say this is a dice, this is a dice, and we throw a die, then you will have one here and maybe two here and then three here, something like that, isn't it? So if you throw this die, how many outcome are there? Can you guess how many outcome are there? This you will get 1, 2, 3, 4, 5, 6. All these are possible outcome. You throw a die, you will get number 1 or 2, 3. If you stop here until 5, this is not exhaustive. Okay, so if you write all the outcome 1 until 6, that is called exhaustive. Mutually exclusive outcome means no two outcome occur at the same time. Okay, which means for example, before I go to this example, maybe winning a football game. Okay, what is the what do you call outcome for a football game? You can win, you can lose, you can draw. These are the outcome. Can you win and lose at the same time? Cannot. Okay, so winning and losing is mutually exclusive. Okay, draw and lose is mutually exclusive. Okay, so mutually exclusive means no outcome can occur at the same time. Okay, so a sample space is random experiment list all possible outcome. That outcome must be exhaustive and mutually exclusive, which means cannot happen. Mutually exclusive means it doesn't repeat. It doesn't happen at the same time. So if you notice here, this is the 1 to 6 is mutually exclusive, because the probability of getting one here, 1 appear differently, 2 appear differently, 3 appear differently, everything is different. Okay, it doesn't coincide. Okay, it doesn't coincide. So what I mean is here exhaustive plus exhaustive and mutually exclusive, that is known as sample space. Requirements of probability. Probability must lie in between 0 and 1. That one I think you guys know, you have learned in the school. Probability is always in between 0 and 1. An individual outcome of we are not yet into exercise, we are just learning some terms, some important terms. Okay, I'm not going to ask this in the exam, just listen. Simple event is an individual outcome on a sample space. So for example, let's say that's now the sample space I denote it by S 1 2 3 4 5 6 7. Sample space is, let's say for example individual outcome. What is the probability of getting 1? Okay, what is the probability of getting 1? How many 1 are there? 1 over how many altogether, how many number here, outcome here? 6. This is the answer. What is the probability of getting 3? How many 3 are there? 1. How many outcome altogether? 6. 5 also same. So all these each of them is known as single outcome, single event. Sorry, it's not single event. All these are single outcome, single outcome probability. And this single outcome, since all are single, isn't it? Single 1 3 and 5, 1 3 and 5 all are one single. Okay, we denote this as simple event. Simple. Now if I want to combine this, I can combine like what is the probability of getting odd number. Here odd number, I basically I combine everything. One odd number is what? You can see the odd number here is 1 3 and 5. So 3 odd number out of 6, I get 1 over 2. This, when I combine more than one simple event or single outcome here, this is known as event probability. And event is a collection of set of more simple events. So when I combine this is known as even probability. This is simple even probability. This is even. Even means more than one simple event combined. Okay. Okay, that is some terms. Okay. Now let us go to the main part today. Probability of combined events. So the type of first probability we're going to see is the intersection. We call it as joint probability. Okay, joint probability. The intersection of events A and B in the event occurs, both A and B occurs. Okay, so A and B must occur together. We call that as the probability of intersection, and the special name for it is joint probability. If you look at this example here, determinants of success among mutual fund manager. Okay, so I'm going to denote this. Fund manager graduated from top 20 MBA program. I denote by A1. A2 is non-top 20 MBA program. Fund outperformed the market, B1, not outperformed, B2. So basically, you are a manager, fund manager. You invest money, people's money. Yeah? You invest your client's money into some what do you call some the inside some stock market. Okay, and then you see whether the share market goes up or down. Okay, that's how it goes. So if you invest your client's money inside some share market and it outperforms, it's doing good, what is the probability? 0.11 for top, if you are coming from top 20 manager, top 20 MBA program. If you are from non-top 20 MBA program and you invest and you are doing good, the probability is 0.06. The chances for you to get the thing. Yeah? You are from top 20 MBA program, you are not doing good, is 0.29. You are non-top 20 and you are not doing good, 0.54. It's actually you are good, here you are doing good, 0.11. This is non-top 20, normal, from normal MBA program, and you are not doing good, 0.54. Now if I want to the joint probability comes here. You can see here this one is a combination of A1 and B1. So this part here, actually this probability is P A1, not enough space, I write here. This part here, okay, is actually probability of A1 and B1. This is 0.11. You can write it like this. This is known as joint probability. This is also equivalent to intersection. Yeah. If you learn set in the school, okay, if you learn set here, this is intersection, the same notation. And intersection, you can use same notation. Okay. And intersection, and mathematically it is plus, all are same idea. Okay, so if I want to denote this, 0.29, how I can write 0.29? I can write it as A1. I'm going to use intersection form, intersection B2. That you will get 0.29. And then same goes here, A2 and B1. you will get 0.09 and A2 and B2 you will get 0.54. So each number here, if you want to write in terms of notation, this is the notation. And what is the name of this probability? Joint probability. If you see a table, in the table they already give you the probability. That is basically your joint probability in between this variable and this variable, this variable and this variable, something like that. Okay. Now that is the idea of joint probability. Okay. The next one is marginal probability. For marginal probability, you can see here, computed by adding across the rows and down the columns. So if you plus this one and this one, if you plus this, okay, by row, if you go by row, if you plus this is actually probability of A1, this one. What is this row? A1, isn't it? If you take all the probability here, you plus, that is the probability of A1. If you plus here, what do you get? 0.11 plus 0.29. You will get 0.14. Okay, that is marginal probability. Same goes for A2. A2 is what? If I want to find the probability of A2 only, what should I do? You take this one plus, you will get 0.6. If you want B1, if you want to find the probability of B1, you plus this 0.11, 0.06. And if you want to plus this, what you get? .83. So that's how you find marginal probability. Okay. Now basically marginal probability, if I want to go within a bit into the notation, just now what is 0.11 is actually A1 intersect B1, isn't it? This is actually A1 intersect B1, and 0.29 is A1 intersect B2. So this is actually your notation wise. This would be your, if I want to find A1, I take all the intersection. This is B2. I take all the intersection with A1 and I plus. That is the idea. If I have another column here, maybe B3, so I just plus here B3. Okay, same goes to A2. How I can write A2? A2 intersect with B1. A2 intersect with B2. if I have B3 I plus, if I have B4 I plus. Okay, so if you plus all the joint probability of A2, you will get A2. That's the idea. Okay. Later I share the complete slide, don't worry. So you can see here that I have written here, okay, this is the thing, the joint probability, and this is the condition, marginal probability, all these things. Okay, if you here you plus this, you plus 0 by column, you get 1, you plus by row also you get 1, so total probability should be 1. Okay. Next is conditional probability. Okay. Conditional probability is conditional probability of even A given that even B. So this if you want to, conditional probability is you are finding a probability after knowing some historical data. That is conditional probability. For example, here you know the probability of B, and then you are finding what is the probability of A. Okay, something like that. The probability of even A given even B is, okay, you know what is the probability of B, you are finding probability of A. So what is the formula? If I write like this, you write probability of A and B over probability of B. The probability of even B given even A, so if you want to write the other way around, which one happened first here? The one behind, this one happened first. Okay, this one happened first. In this case, how you write? Okay, so here probability of even B given even A. Okay, this is the formula. Later I'll share you the full slide. This is just for you to see. Look at this example. Suppose that we select one mutual fund at random and discover that, I put this as example 1. Suppose that we select one mutual fund at random and discover that it did not outperform the market. What is the probability that a graduate of top 20 MBA program manage it? So given condition, what is given condition here? given condition is, suppose that we select one mutual fund at random and discover that did not outperform the market. Did not outperform the market just now is what? We are referring to this one. Did not outperform the market is B2. So given condition is B2. We know that B2 happened first. We know B2 happened first. Okay, out of this B2 not outperform. What is the probability that a graduate of top 20 MBA program manages? So what is the probability of top 20 MBA is what? A1, isn't it just now? Top 20A is A1. So seeking probability, I call this as seeking probability. Seeking probability is A1. So basically what we can write, we are finding A1 given that B2. Okay, this is given first. This is given already. Okay, so what is the formula? Probability of A1 intersect probability of B2 over B2. So A1 B2. What is the probability of A1 and B2? That is 0.29 over B2 only 0.83. If you do this, you will get 0.349. Now under conditional probability, there's one special case, known as independence. Under conditional probability, there's one case known as independence, special ideology. Two events A and B are said to be independent if with this condition. Okay, if you finding this probability is equal to this probability, then A and B are independent. Same goes for this one. Okay. To be more clear, let's say for this one, let's say U is umbrella, you bring umbrella, and R is raining. Okay, let's say every day you bring umbrella, the probability of every day you bring umbrella is, let's say the probability of you bring umbrella is 0.4, let's say. And then if it is raining, let's say it's raining, the given condition is today is raining. If the probability of you bringing umbrella is not same with 0.4, maybe 0.6. Okay, I repeat, every day, whether raining or not raining, the probability of you bringing umbrella is 0.4. Now let's say then today it's raining and suddenly the probability of bringing umbrella changes 0.6. Does the raining influence you? Because the probability changes, isn't it? Because the probability is getting higher now. So the raining change your probability now. Am I right? So this is not equal to this one. So this is U and R is not independent. U and R is not independent. Because normally you bring umbrella is 0.4 and today is rain and the probability of you are bringing umbrella is 0.6 changes, isn't it? So when it change, it's not same, not independent. But let's say this is not, let's say this is 0. Still 0.4. Your every day you bring umbrella is 0.4 and then suddenly it's rain, still the probability you bringing is 0.4. Does the raining influence you? Okay, does the rain do anything to you? No, nothing, because the probability is same, which means PU is equal to, so U and R is independent. Okay, U and R is separate. Okay, R doesn't influence you because the probability is still same. If your R influence you, the probability changes, then U and R not independent. Okay, so this is independent. That's how you identify independent, non independent. Okay. Look at this example 2 here. Determine whether the event that a manager graduated from top 20 MBA program. Top 20 MBA program is what? A1. And the event fund outperformed the market. Outperform the market, isn't that is B1? Okay, A1 and B1 is independent event or not. So what you can do? You can find this one. You can find this one. How much is this one just now? Did we find this one just now? This is PA1 B1 over B1. This one will give you A1 B1 how much just now? A1 B1 is 0.11 and this is 0.7 and this will give you 0.647. Now what is PA1? PA1 is 0. You can see here 0.4. 0.4, this is 0.6, not same, isn't it? Okay, so A1 not same to A2, so A1 and B1 you can write not independent. Okay, not independent. That's how we prove. Some of you might think that, some of you now might have the, some of you now asking me whether can we, in that case because they said A1, to show A1 and B1 not independent, you can do like this, or you can also find like this, B1 A1 also can do like this, B1 intersect A1, this is probability of B1 A1. Okay, B1 A1, see B1 and A1 is same with yes. Who is this?
Sorry, sir. Can I ask?
Yeah, can.
Where did we get the 0.647?
This one?
Yeah, that one.
0.11 divided by 0.17, isn't it?
Or just divide it and then we get 0.647?
Yeah.
Okay. Alright, sir. Thank you.
Okay. We want to show that A1 is A1 and B1 independent or not independent. Either you find this one and show that like this, or you find this one, either one, or I put here or, no need to show both. B1 A1 and A1 B1 are same. Just want to write here, probability of A1 B1 is equal to B1 A1. You switch the place, that's it, can. This one can. A1 intersect B1 is the same, B1 intersect A1 is the same thing. Okay, so just now we found this already, 0.11 divided by probability of A1 is where? Probability of A1 is 0.4. This one, if you press in the calculator, 0.275. And then after that, what you have to find? You have to find B1. What is B1 here? B1 is 0.17. You can see here 0.17 and 0.275 is not same. So basically what you are doing is you are telling B1 A1 is not the same, okay, as, so you can still write A1 and B1 not independent. Either one you can show. If they are asking whether A1 and B1 is independent or not, you can do like this, or you can do like this. Either one of them. Both will give you same answer, not independent. Right? So that's how you determine whether it's independent or not. The next one is a union. Union is with the word of or. So the formula for union is this is the formula for union. A or B. Okay, just now for n, where is it? For n I told you in words it is and, in notation is intersection, and in mathematical notation is plus. Sorry, not plus. I'm sorry, not plus. This is multiplication. Sorry. And intersection multiplication. For or, either or union is, so you know the in the set, if you learn set in mathematics, or this is union u, and then the mathematical notation is plus. So that's the difference between union and joint probability and union probability, union of events. So this one I can write it as, if I want to use the set notation, it's the same formula. Yeah, I can write it like this. Determine the probability that a randomly selected fund outperformed the market or the manager graduated from top 20 MBA program. Determine the probability that a randomly selected fund outperform the market. Outperform the market is B1, or the manager graduated from top 20 MBA program. This is A1. So if I want to do this, I can write B1 unite A1 like this. And from B1, just now we know this is 1.0.17. A1 we know this is 0.4 minus intersection, just now we know this is 1, and you will get 0.46. Okay, that's the answer. Alright, so we will stop here. Today's class is a short class, as I mentioned to you. These exercises, okay, is like this. Tomorrow, I think tomorrow I will meet one of you. Tomorrow we will have a tutorial, if I'm not mistaken. So during the tutorial, we had to go through the tutorial. I need to finish the chapters. So once we finish the chapters, we will go to the tutorial and do the exercises. Okay, so after this, for tutorial, I'm going to meet each of you. This lecture is a combined lecture, section 5 and section 6. I'm not sure tomorrow is section 5 or section 6, I need to see, but we are going to use the same link overall. And tomorrow we will do some exercise, this one, and then move on to the next part of probability. So maybe tomorrow in the tutorial, maybe hopefully I can finish the first chapter, and then we will do some tutorial. Okay, all right. So for today, if you have time, try exercise 1, 2, 3 and 4. Exercise 5 I don't recommend, even though I put here, kind of complicated, but you can try all before I give the answer, before we discuss in the class. In tutorial this week, we are not going to, even though I share the tutorial exercises, I'm not going to do that. I'm going to finish the chapter first for each in each section. Okay, can you guys understand so far what I'm telling here? All right. So today is a short class. Normally the class go until 1.5 hours. Okay, so today I don't want to burden you much. Now I need a favor from you. I need a favor from you. Um, um, I need a favor from you. So I'm recording the class, so I'm just going to stop the recording, but you guys don't leave yet. So we finish here. Okay, we continue this in our tutorial. So I'll see you in tutorial, but don't leave yet. Hold on for a while. I'm going to stop the recording.